This video provides an introduction to SimplexNumerica. It is the first part of a short series. We begin by downloading the installation program from the SimplexNumerica website www.simplexnumerica.com. Go to the download section at the top of the page. Then select Download Simplex Numerica 64-bit. Since the zip file Simplex64 is located on Google Drive, a preview appears here indicating that the file is too large to be displayed by Google. The file is therefore too large for the Google preview. Nevertheless, you can still click on Download here. So I click on the Download button here. Next, a message appears stating that Google Drive cannot perform a virus scan on this file. This is because the file is larger than 100 MB. It also states that the Simplex64 zip file is too large and cannot be scanned for viruses by Google. However, since this file has already been scanned by several virus scanners by the manufacturer and has been classified as virus-free, we can assure you that this process does not need to be repeated. So you can safely click on the button. Continue anyway, download anyway. Now you can see the current download history. A message appears indicating that the Simplex64 file is being downloaded for the second time for this demo. After downloading, the file should be opened. This refers to the zip file. After opening the zip file, you will see that the program inside is called Simplex64setup.exe. You can now run this program or unzip the zip file first. It doesn't matter. You can also launch or open it directly in Windows Explorer as stated here. Now another somewhat dubious message box appears, which is also displayed by Edge or Google Chrome. The computer has been protected by Windows. This is where it gets dubious. Since Windows Defender does not yet recognize the zip file Simplex64, it does not want to execute it. But we want to execute it, so we click on More Information. This is not clearly stated here. However, you can still select Run. This will start the SimplexNumerica setup program. An earlier version has been found, which you can either uninstall first or overwrite by clicking Accept and Continue. The installation will take a moment. Once it is complete, you can continue with the installation. Every Windows application is based on a program library. SimplexNumerica is based on a well-known Microsoft C++ library. Therefore, this must also be installed. If you have already done this, you can uncheck the box in the dialog box shown here. Usually, you can uncheck the box during the later program update. The following apps were installed by the setup program: SimplexNumerica, Simplexity app, Simplex Slideshow, Simplex Editor, Simplex IPC, and the IPC test client. However, SimplexNumerica and the Simplexity app are only stored on the desktop. You can place the other apps on the desktop yourself if you wish. You are now in the Windows Programs section. Now we start the program, which appears immediately without much delay. We click on the thumbnails on the left and select any chart by clicking the left mouse button. But first, we want to start with the startup dialog. This startup dialog usually appears automatically when the program is started for the first time. You can also call it up at any time using this icon or the F1 key. The startup dialog is divided into two concepts. On the one hand, there is the Excel concept on the left-hand side, and on the other hand, the conventional method concept from SimplexNumerica. The difference lies in the creation of a graph. Either you select a chart in the thumbnail window on the left-hand side or first select the data on the right-hand side of this help dialog. An assistant appears immediately. It shows, for example, that you should simply click on a symbol. If you click on the physics symbol here, a new window opens immediately with a chart that is virtually pre-generated with so-called dummy data. You can easily change this data in the table editor, key F3. Of course, you can also import data. The z-axis of the table can be shown or hidden in the ribbon bar. If you click on the delete table, the dummy data is deleted and you can view the data in view mode. As with a database, there is a view mode and an edit mode. It is best to turn off the view as this makes it easier to enter data, just like in Microsoft Excel. Let's start by entering some sample data, whatever comes to mind. Editing is done in the same way as in Microsoft Excel. The functions that can be used, such as removing cells or inserting new cells, are identical. If you want to view the data in the chart, you can click on the corresponding button at the bottom or select the F3 key or graphic view in the ribbon bar. You will then immediately see the generated chart that we selected from the thumbnail menu window. The cursors can be hidden either via an icon in the ribbon bar or directly in the chart. Our goal now should be to connect the data points. But first, let's fix the chart in place so that it doesn't keep moving around. The lock option allows you to fix the chart so that it doesn't keep moving around on the screen. In the ribbon bar, you can display the polygon which connects the points. Now we would like to select an algorithm, for example a B-spline. This is always good for a demo as you can go into the approximation. Among the B-splines and in the Properties windows under Numerical Algorithms, you can easily calculate it. Since we have selected a template with a filled curve, we now deactivate it so that we can view the B-spline without filling. Next, we save our evaluation under Introduction 1. I had already done this before. Introduction 1 should now be stored on the hard drive in the background as our first evaluation. Next, we want to implement alternative 2, i.e. editing tables from which we then generate the chart. Previously, we had selected a chart that already contained dummy data. This time, as with Microsoft Excel, we first want to enter data into a table and then generate the chart from it. This is essentially the reverse approach. It is up to each individual to decide which is easier. Okay, let's add another graph, i.e. another data series, by copying and pasting it. Let's change this data a little so that it looks different. They can also vary in number. They don't have to be the same number, nor do they have to be equidistant. They can be whatever you want. We can not only enter the data using the keyboard, but also import it as Excel, CSV, or other data formats. But let's enter it here for now. Then we select it and choose the chart again. The window is automatically divided into two parts, but only if we want it to be. We can also set it so that it is not divided. Here it is now divided, which is a little confusing in the reduced display. The screen is kept a little smaller for this presentation. And so we see our physics chart again, which fits quite well. We turn off the cursors. This can also be done using the icon we just clicked on. We select Algorithm again, then Approximation, and then B-spline. This time, however, we want to apply the B-spline to both graphs at the same time, not in the Properties but at the top with Assign to All Graphs. Then we select Recalculate Graph. All graphs are immediately calculated with the B-spline. We want to turn off our fill again. Voila, we now have both graphs with a B-spline. We also want to save this as an evaluation with the name Introduction 2. This will then be our introduction number 2. We can close all windows at once except for the one we are currently in. However, we can click on Close Window or simply click on the cross. Next, we want to press F1 to call up the Help dialog again. This time we want to proceed according to the following concept. How do you use the spreadsheet? According to the Excel principle. Then sample data opens. And our wizard appears again. Tells us exactly what to do. What should we do? We have loaded a sample table here. Now please move the so-called splitter bar. This is just so you know that there are a few more tips behind it. We can close these again or use the icon in the rib bar. We can hide or show it. Now let's move on to the next tip in the balloon. We now want to place the cursor in an empty row. The empty row can be chosen arbitrarily as in Excel. Then we'll see how to proceed. We can call up the function dialog box of the formula function list, enter sign, select assign function and then assign it to our selected cell. So we should process the data in the same way we do in Excel. Then let's do that. Let's start again from the beginning and create a new function, this time not a sign but a cosine of a cell. Cosine. There's the cosine. Now we just have to select the cell. Let's take D26. We enter D26. Voila, we have stored the cosine of D26 in H26. Okay, but that's not our goal either. Our goal was to generate a chart from this table using the Excel function. To do this, we select a table area and click on our physics chart. The physics chart splits again. We can also turn off the parts later. Now we drag and position the window. We can see that the physics chart is not ideal for this data series. Let's try another one, for example a 3D business chart. This one with the vertical clustered bars. That looks better. Let's move it around a bit and make it bigger or smaller. You can do this using the small yellow dots. This allows you to enlarge and reduce it. With these pins you can move the text to where you want it. The text can be changed in the properties. Okay, that was part 1 of the SimplexNumerica introduction. Thank you very much.